Okay. Take the first problem. Problems on motion in a plane. A ball is thrown into A. A ball is thrown into A with a speed of 62 meters per second. With a speed of 62 meters per second at an angle of 45 degrees with the horizontal. At an angle of 45 degrees with the horizontal. Full stop. 45 degrees with the horizontal. Calculate A, the maximum height attained. Calculate A, the maximum height attained. B, the horizontal range. Horizontal range. C, the time of flight. Time of flight. D, the velocity of the ball after 4 seconds. The velocity of the ball after 4 seconds. Okay. See, in the examination, the problem for 5 marks will usually consist of finding the first 3 data: maximum height attained, horizontal range, time of flight. But in this problem, the 4 data, that is, you need to find the velocity of the ball after 4 seconds. That itself is a separate problem for 5 marks. But I have included 2 problems in one single problem. The first 3 aspects, that is height, range and time of flight, can be found by direct substitution of the formula. We have respective formulas for each one of them. The 4th one, let's see how to find the velocity of the projectile. That's the ball, which is thrown at an angle of projection of 45 degree. What is the value of theta in this problem? 45 degree. Okay, now let's find one by one by using the respective formula. The first one, A, maximum height attained by the projectile. Attained by the ball, which is the projectile in this case. Maximum height attained by the projectile or by the ball is, what is the formula for maximum height? Yeah, you know it is u squared sin squared theta divided by 2g. U squared sin squared theta divided by 2g. Now, given u equals 62 meters per second and theta is 45 degree and g value we take it as 9.8. It is understood to take g as 9.8 meter per second square. So directly substitute these values in this formula. H equals u square, that is 62 into 62 into Sin 45 into sin 45 divided by 2 into 9.8. Theta is 45 degree. So sin theta becomes sin 45. What is the value of sin 45? 1 by root 2. Sin 45 is 1 by root 2. That is 1 by 1.41. Root 2's value is 1 by 1.41. This will give around 0.7. You can check in the calculator. 1 by 1.41. 4. To be more appropriate, let's take it to 3 decimal places. How much is 1 over 1.414? 0.7? Yes. This is 0.707. It's better you remember this value. The value of sin 45 or cos 45 decimals is 0.707. 707. So H equals 62 into 62 into 0.707 into 0.707 divided by 2 into 9.8. 2 into 9.8. When you simplify all these, you will get 98.6. 98.6 meters. So the maximum height attained by the projectile is 98.6 meters. Now let's find out the second aspect. Now what did you find here? What did you find? What did you find? Yes. This is x-axis, this is y-axis. The projectile is thrown in the air at an angle of 45 degree. It reaches the maximum height. This height you found now. The h in this case for this problem is 98.6 meters. Now the second one we need to find is the horizontal range. OA is the range. So now we need to find the length of OA. Okay, take the second one. Horizontal range. Attained by the ball. Attained by the ball. What is the formula for the range? Range of the projectile. U square sin 2 theta divided by G. R equals U square sin 2 theta divided by G. Direct substitution again. Direct substitution. Now putting on the values. 62 into 62 into sin 2 times of 45 divided by 9.8. That is 62 into 62 into sin 90 divided by 9.8. Okay. 62 into 62 into 1 divided by 9.8. Why? Why it is 1? Sin 90 is, simplifying, you will get the answer 392.2 meters. 392.2 meters is the horizontal range. The third one is to find the time of flight, which is 2u sin theta divided by G. Time of flight is given by the formula 2u sin theta. Time of flight of the ball. Time of flight means how long the ball remained in air. That's called as time of flight. And in fact, you know that the time of flight of a projectile is equal to the time of ascent plus time of descent. And it is the total time of both these, and it is given by a formula T equals 2u sin theta by g. And now we substitute the respective values. 2 into 62 into sin 45 divided by 9.8. It is 2 into 62 into sin 45. Sin 45 in decimal, just now I told you, 0.707 divided by 9.8. On simplifying this, you would get around 8.95 seconds. T equals 8.95 seconds. So the first three details have been found out by using the respective formula. Now let's proceed to find the fourth one. And before that, let's understand what we actually need to find. Now I want you to pay attention now. You need to find the velocity of the ball after 4 seconds of launch. The time that has elapsed since you launched the ball is 4 seconds. So the ball has started traveling. 4 seconds have been over. What is the velocity of the ball? In this case, the velocity of the ball is given in two ways. Since the ball is undergoing two-dimensional motion, it has got velocity along x-axis, that is Vx. Vx is the horizontal velocity of the ball, and it is also going up and up. So it also has Vy. So you need to first find out Vx, which is the horizontal velocity. Always keep in your mind that when you find Vx of a projectile, the horizontal velocity is non-accelerated motion. Vy is accelerated. So the situation is like this. Vx is the velocity along x-axis. Vy is the vertical velocity of the projectile. So this is the projectile. Now, how many seconds have been over? 4 seconds. Let's say at the end of 4 seconds, 7 t equals 4, let the projectile be in this position in A. So at this position, the entire velocity of the projectile is split along horizontal and also along vertical. Along horizontal it is Vx, along vertical it is Vy. Now, the resultant of these two velocities is V, which is the actual velocity of the projectile at t equals 4. What is the velocity of the projectile after t equals 4 means? Do you give horizontal velocity or do you give vertical velocity? You need to give the resultant of these two. To find the resultant, you have to first find Vx and then Vy. And since angle of projection is 45 degree, yesterday we have learned one formula. R is equal to root of p square plus q square plus 2pq cos theta. Here p is Vx, q is Vy, theta is 45. Okay. Okay. First let us find out the horizontal component right now. The horizontal component of the velocity, the horizontal component of the velocity in bracket Vx remains constant throughout. because it is non-accelerated motion. Write that also. Because it is non-accelerated motion. Okay. We know that the horizontal component of the velocity Vx. What is the formula for horizontal component of the velocity? U cos theta. That is equal to 62 into cos 45. That is 62 into 1 by root 2. 62 into 1 by root 2 gives around 44.3. 44.3 meters per second. meters per second. So the ball is moving horizontally. That means along the x-axis, it is moving at a velocity of 44.3 meters per second, like this. Now we calculated Vx. We need to calculate Vy. Next line you write. The vertical component of the velocity Vy. Instead of remains constant, you should write keeps changing. Keeps changing throughout. Why? Because you need to write that sentence. Because it is accelerated motion. Now we know that Vy equals V equals U plus AT. I will use this equation. It is not a rule that you should use the same equation. Any equation pertaining to velocity, because you are finding velocity. Vx equals Uy sin theta. And what is Uy here? Uy is U sin theta. This is the value of the velocity of the projectile along y-axis. What is G? G is minus G. You get it? Why? Because it is the vertical motion, it is against gravity, and T equals force. T equals force. So substitute these values, you get Vy equals U sin theta minus 4G. Or Uy equals U sin theta 62 into sin 45 minus 4 into 9.8. Are you following? Okay. No? This one. Okay. Yeah. The Uy is U sin theta, and this way it is V. Correct. You are right, because I am substituting for. You are right. But Uy is U sin theta. It is the vertical component of the motion. Now here, one thing you need to understand. What is the difference between Uy and Vy? Let me just make it clear. No. It's like this. I need to just write this as Uy in fact. This is Vy, this is Vx, this is Vx, which is in terms of Ux, and this is Vx, which is in terms of Uy. That's all. So Vy equals 62 into 1 by root 2 minus 4 into 9.8. Please simplify this.
4.0.
Simplify.
4.0.
How much?
4.0.
Yeah. 4.64. 4.64 meters per second. 4.64 meters per second. So this way it is 4.64. Okay. Now you tell me what is the resultant of this velocity. See here, this is Vx and this is Vy. This way the velocity is 4.64 meters per second. Velocity is a vector. This way it is 44.3 meters per second. So what is the resultant of these two? This is the resultant. Okay? Okay. Now write in the next line. The resultant velocity of the ball after 4 seconds is Vr, which is square root of Vx square plus Vy square into 2 Vx Vy cos theta. I want to make one more clarification here. What is the value of theta? No, theta is 90 degrees because the angle between Vx and Vy is 90 degrees. 45 degrees is only the angle of projection. But how is Vx acting? Along x-axis. How is Vy acting? Along y-axis. So what is the angle between these two vectors? 90 degree because they are acting along the two perpendicular axes. So Vr equals square root of 44.3 square plus Vy is 4.64 square plus 2 into Vx into Vy into 0 because cos 90 is 0. Theta is 90 degree. You can make it out that theta is 90 degree. Angle between Vx and Vy is 90. So Vr equals, simplified, you may get around 44.5 meters per second. 44.5 meters per second. You get that value? Okay. Square root of 44.3 square plus 4.64 square. Square, add and take the square root. It's around 44.5 meters per second. This is the magnitude of the velocity. What is the direction of this velocity? I am asking you one more question. This value of the resultant velocity, 44.5 meters per second, will be acting in what direction?
The direction of the height.
In the direction of
That is Vx.
The greater velocity.
greater velocity. Okay. To find the direction of the resultant, we can also find the direction in this simple way. You just write the direction of this resultant velocity. The direction of the resultant velocity direction of the resultant velocity VR is just given by tan alpha. Yesterday we derived the expression for tan alpha. You know, in this case, since angle is 90 degree, you can directly take tan alpha equals Vy by Vx. Vy by Vx. What is the value of Vy? It is 4.64 divided by Vx. Vx is 44.3. 4.64 divided by 44.3 is 0.104. This is tan alpha. So tan alpha equals 0.104.
ನೋಡು ಇದು ಕಾಲು ಕಾಣಿಸುತ್ತೆ ನೋಡಿ ಯಾವ ಆಂಗಲ್
So alpha equals tan inverse of 0.104. If you look into the natural logarithms and find out the value of this, it's around 5.09 degree. This is an extra information which is not asked, but anyway, you just know how to do something for the direction of the resultant velocity after a given time. Okay. Any doubt in this problem? This is a full length problem. If you are perfect with this, it's like, you know, doing 50 problems in this lesson.